Okay, how to import and save data. To import some content, some data, we will need to use this instruction, load and the name of the file that contains the data. To save data, we have a lot of options, but the most common are to only type save and press enter, and we save all the workspace into matlab.mat file. And also we can save only one variable, so we will need to type save and the name of the variable. Okay, let's see how to plot. Let's open example number 3. Here we generate an array from 0 to 4 times pi and 1024 values. We calculate the sin of these values and then we plot them. The way to plot this is very easy. Here we have the command, the plot command with 3 input parameters. The first one will be the values of this axis. The second one, the values of this axis. And the third one, which is optional, is the color that you want the figure to be painted. In this case, it's blue. There are a lot of other options. So let's launch this example and we obtain the scene function painted in blue. But this is a very sad figure. We need to add some labels on the axis and a title and so on. So let's see how to do it. We launch a grid to see in a better way the values of the function. This X label is the label for this axis. The Y label it's for the other axis, and title is of course the title of the figure. So let's go to MATLAB, press any key, and we have the grid, the title, and the titles of the axis. Okay, now imagine that we want to plot another function into the same figure. So we need to tell them that to hold on this figure, we add the other function. In this case, we will have the cosine function, and we plot it in the same way: x-axis values, y-axis values, and the color. In this case, it will be red with a dotted line. So let's go back to MATLAB and press any key, and we go to the figure, and we see that this function, the cosine function, is depicted here. You can do a lot of things here, like zooming or checking some values. In this case, you can see x is 0.94 and y it's 0.58 and so on. Okay, you can also change the values of the axis of the figure. You can plot a lot of things in the same figure. And also you can do, this is only an example, you can plot 3D functions. This is the scene without the first parameter, so it's a scene in the x-axis, and also with no axis specified here. You don't have the x values, so you have every sample numbered. Okay, let's go to the 3-dimension figure, the 3D figure. You can see it from different perspectives, and to change its view also the way that you want. Okay, there are two types of files for the source code in MATLAB: scripts with no input and or output arguments, like our first example, and functions that have input and output arguments. There are a lot of there are so many types, but in this course we only need these two. This is an example that you have in your course repository of a very simple function that receives as an input the power of a function in bats and returns this power in dBms. So you already know the formula, the expression to calculate this power in dBms, but the syntax, the MATLAB syntax is this one. You say the name of the function and the parameter in parentheses, and you obtain, this is the parameter that you return. So if we go to MATLAB, we can say that the power in dBm, for example, it's equal to bats to dBm, the name of the function, and for example 100 bats, and we obtain that this power in dBms is 50. So it's a very, very simple way to work with MATLAB. A very important remark is that the name of the file, in this case y2dbm.m, needs to be the same name as the function. So in this case, the two of them have the same name. A very important thing in MATLAB, a very powerful tool, it's the request help tool. Here, if you go to the MATLAB environment and you go here to request support, here you can ask the MathWorks community, the MathWorks staff, every doubt or every problem that you have. So you can tell them, okay, I'm working with my RTL and it seems not to be working fine. I am not able to change its center frequency, or it does not receive something that it should do, or whatever you want. They will be very happy to help you. Also, you can request this help in the MOOC forum. So you have a lot of options. Of course, you can also request MathWorks help in that email that you have in the screen, the support@mathworks.com. Okay, the last thing that we need to know, it's about the flow control and the if-else statements. If-else is used to determine if a condition is satisfied to execute one part of the code or the other. So, in this example, in example number 4, we have a very simple example. We have the same power in dBm that we calculated in the previous function, in the previous example, and we have a branch here. If the power exceeds 20 dBms, you will display this phrase. But if this power does not exceed or is equal to 20, you will display this one. So let's see what happens if we execute example 4 in MATLAB. The power in dBm and example 4, and for example the same power in bats as before. We obtain that the power is higher than 20 dBms. It is 50. So it's right. If we say, for example, instead of this, we say that a very low power, we return the output that says that the power is less than 20 dBm. We know that this is true because the power is minus 40 dBm. So that's right. This is a very, very powerful tool also. And the other one, it's the for and while statements. Here, this is a loop, what is called a loop. Imagine that you need to implement an instruction many times, to calculate something a lot of times. Let's say to do the same thing over and over again. So you only need to know how many times you need to perform this operation, or under which condition this operation should be executed. This is the for loop. The other example is the while loop, but I strongly recommend you to use the for loop, especially if you are not very skilled in programming. It's easier to handle. I have a variable, I, it starts in 1, goes 1, 3, 5, 7, remember the semicolon notation, and it ends when I is equal or higher to the value of times, and the loop only displays the content of this variable. So let's run this example. Pay attention that this function has no output arguments, but it has an input argument, the times, which is the times that we want this example to execute. So we say example 25, and what it will do is to go from 1, 3, 5, 7, up to 25. Let's see it. Okay, we obtain a column vector, not a column vector. We display in the screen as a column 1, 3, 5, 7, and so on. Okay, if we change times to 3, we will only obtain 1 and 3. If we change here, for example, 1, 1, jumping from 1, we will have 1, 2, 3, 4, 2 times. We save this new version and we launch it. We have 1, 2, 3, 4, and so on. Okay, that's an example of what you can do with for on while or while example. And to finish this video, some remarks. Remember that in MATLAB everything is a matrix. So loops, nesting loops one inside the other and so on, is very, very inefficient here. It's everywhere inefficient too, but in MATLAB it's more inefficient. So to optimize the way you work with MATLAB, you will need to vectorize everything. This is to have all the data that you need to process into a same row or into a same column. Another useful tip is to pre-declare matrices. Also, which is a very advanced skill, you will need to debug your code. MATLAB has some tools to debug your code. And the most important advice for you: do not reinvent the wheel. Try to use always built-in functions every time you can, because these functions are already tested and have a lot of documentation, and a lot of people will help you using them. So that's it. Sorry for the very long video. Thank you for your attention.